Okay, so here we're given a question. It says the top view and the front view of a non-transparent conical cylinder drawn in first angle orthographic projection. So this is the top view, this is the front view here. Okay, so the instruction is simple. It's saying you have to draw two turns of a left-handed, meaning clockwise, helix starting from point P. So we have point P here. So when they're saying it's left hand, it means it's going this side, meaning you use your left hand, it's gonna go this side, so it's gonna turn like this. When they're saying it's a right hand, it means it's gonna turn this way. So in this case we are using a left hand, right? So the first thing that we have to do is to divide our circle as usual into 12 equal parts. Okay, so we're gonna use our 60 to divide this circle into 12 equal parts. Divide like this. It's simple. We're always doing this in EGD, so it must be not a problem or a challenge to anyone. It's simple and straightforward. Dividing a circle, we've been doing this since grade 10. So then we divide this part here. Then we are left with the horizontal line down here, which is this one. So we have divided our circle into 12 equal parts. So what you want to do is you want to number your circles. So we can start from here as 1, going clockwise, 2, 3, 4, 5, going on until 12. After numbering, remember we want to develop a helix that has two turns, meaning it has to go from here P to the half. That will be one full turn. From the half to the top will be another full turn, meaning we're gonna have two turns. So we can put our O here, which is our top, our peak, I can say. So they said the height here from P to O is 150 millimeters, and the radius of this circle is 50 millimeters. So what you want to do is get first you have to get the half of this height, so that you can have two full turns, right? So the half of 150, we say 150 divided by 2 is equal to 75. So we are going to have our half here, our 75 millimeters, meaning now we divide it here. We're gonna have our half right there. Sorry, I missed that. Our half is just here. Okay, so that's our half, right? Then the next step is you want to get 12 equal horizontal lines from here to here, and then from here to there. So since it's 75, we cannot divide 75 by 12. It's gonna give us like a number with the commas and stuff. So what you want to do is use like a simple method that you always use to get like to divide the line into equal parts. And like it could be any length. You simply use your ruler I can say your t-square or whatever. So I decided to use my 60 for this. So next thing that I want to do is to divide this line into 12 equal parts, right? So it's going to start here. This is I'm gonna divide it into 5 millimeters. Like each part is gonna be 5 millimeters, so it's gonna be 1 2 3 4 5 6 7 8 9 10 11 12. Okay, now we have this part. You want to do the same for this part here. You can simply do it like this. The angle here doesn't matter. You already know that the angle here doesn't matter as long as this is going to be equal line. So I don't need this anymore. I can just rub it off. Alright, but it's not necessary to rub it off. We want to divide this one into 12 equal parts. Okay, so it's 1 2 3 4 5 6 7 8 9 10 11 12. It's 5 millimeters each. So what you want to do is okay, you can number it as from 1 2 3 4 5 6 7 8 9 10 11 12. You can do the same for this one just to be sure, okay, but I've already calculated it, so I don't need to number it. So the next step is you want to connect this point to this point so that you can get 12 equal parts here. Okay, so we're going to try this. Going to try connecting these 2 points. Remember, my t-square here has to be static, meaning it doesn't have to move at all. So we're going to start here. This is going to be 1 2 3 4 5 6 until the last line. Okay, until the last line. So we have our 12 equal parts here. We do the same for this one here. All right, you want to connect these parts, so it's going to be like this. Then we can put our t-square here. You can use 260 or you can use a 645, whatever that you prefer. Sorry, I'm almost missed it. 1 2. You do the same method all over again to get these lines. The reason I'm dividing it into 12 equal parts is because my top view, I decided to divide it into 12 equal parts so that it can be much easier when I want to draw the curve, the helix that is going around it. Some people divide it into 8 equal parts. That's still okay as long as your curve will be accurate, okay, but normally we use 12 parts. So we are done here. Now we just use our t-square. We just use our t-square to get these parts done. Sorry for that. Just use our t-square to get these parts done. I missed these parts. I don't know what's going on. Sorry for that. simple wrap it. That is why you need to always have a rubber, because no one is perfect, right? So you must have an eraser at all the time in case you make a mistake. You do the same all over again until the last part, until the bottom. You can start from the bottom to the top, from the top to the bottom, from the middle to the bottom, then to the top. It's up to you, as long as at the end of the day we're going to have the same equal lines. Okay, so do this again. I missed that again, sorry. I don't know why I'm making so many mistakes, but we are bound to make mistakes, right? You do the same thing up until the last line, okay, until the bottom. Then when it is like this, sorry for this one too. When we have something like this, then it means we are almost done with our helix development. We are about to develop a helix, right? So this is the last one. I don't know why it's giving me problems. And I missed this too. Yo. Okay, so we have something like this, right? It's gonna end there. There's something like this. So the next step is you want to take these lines up to your front view. You don't have to take them up there. You can just take them to the base of your front view, okay? Because this is not a cylinder, this is a cone. If it was a cylinder, we're going to take them up until this part up here. So the next thing that you want to do is you connect your lines from here. All of them, they are going up to the peak, which is our O there. Okay. We've already connected this one, so there's no need to do it again. Remember, use construction lines for all of this. You only use solid lines when you are already sure about what you are doing, and you always use construction lines for construction. As the word is saying, construction. So we are still constructing our helix here. So it's going there, saying the instruction is saying it's starting at P, right? So if it's starting at P, it means we're going to start here. We are going left hand, meaning clockwise. So meaning we're using our left hand, we're going this side, right? So from point P, we already know that it's going to come to this point. We move up, we come here, we move up, we come here, right? Then we move up again, come here, we move up again. You do the same all over again. You move up, from here to here, right? From here we move up again, from here we move up again, you do the same thing all over again. You do the same all over again. Move up again, you move up again, move up again, move up again, we come here, move up again. Then we are going to have our last patch at the peak. I think it's going to be here. Yeah, because if you move up, it's going to start like this. This is you move up like this. This is 110. This is 210s, right? So yeah, if we're calculating, we move up, we move up. From here we move up, we move up, we move up, and we're going there. So I normally use construction line before I use solid line for my curve and scale like this. In case I make a mistake, I normally use construction line. Okay, so you're already sure that you're going to see this pattern. Remember they said this is non-transparent, so meaning this is a solid, we cannot see behind it. So we're going to use dotted lines here, meaning hidden detail. So meaning again from here to here, we're going to see this here. We are going to see it because it's in the front, right? And remember, we are going clockwise. Then we cannot see behind. Then it means starting from here up until here, we are not going to see it. Then from here to here, we are going to see it. So I can start from here, make it a solid line, make it a solid line, make sure it's visible. Then I can make this one a solid line too. Because it's in the front, and this one too, I can make it a solid line because it's in the front too, we can see it. Remember, it's a non-transparent, meaning it's a solid, so we cannot see behind it. They said show all necessary construction and show hidden detail. So hidden detail means what's in the back. We are going to use hidden detail lines, okay, to join these parts. It's simple like this. You don't have to make it trick, you don't have to make it hard. Then for this one too is going to be hidden detail, right? Until that part. So it's going like this. It goes to the back, comes back, it comes back to the front, it goes to the back, comes back to the front. It does the same up until that part. So our answer is supposed to look like this. We didn't miss anything, so this is supposed to be 100% correct.